Hi and welcome back. This video is about accessing raw data. In this video, we are going to use Python to access data from local files. We'll also discuss the structure of some common file formats and how to read them from Python. We start the discussion by opening and reading files. Let's say we have some file in the current folder. The magic function cat allows Jupyter to print the content of a file. So this is our sample data. In order to open a file, we use the built-in function open. In this example, we are opening in read mode, so that's the meaning of the second argument. The function returns a file object that we can use to read the whole content into memory before closing the file. A cleaner way to do it is through a context manager using the with keyword, which will handle some exception and will ensure the file is closed even without explicitly specifying it. This second example is essentially equivalent to the first one. An alternative approach is to use the function readLines, where the content is loaded as a list of lines. The last character of each line is the new line symbol. Sometimes reading big files in memory is not an option, so you need to process a file line by line. File objects can be used as iterables, loading one line in memory at a time. File objects, like other iterables, can also be passed to the enumerate function that gives us also a counter starting from 0. Now let's discuss some common file formats used to represent data. The CSV, or comma-separated values, is often used to share data from spreadsheet, databases, or in general everything that looks like a table. This is how our sample data looks like, with the first line, the header, showing the attribute names. The CSV module in Python offers a CSV reader, which we can use to read a file in CSV format. There are many dialects for CSV that use different field delimiters and new line delimiters, so using this package is better than coming up with a homemade solution. The CSV reader is an iterator, so we can use the function next in order to load up the first line. This line contains the names for the attributes. Once the headers are loaded, we can read each line like we have done before. The CSV reader will return each row as a list. If the data does not present a header, we can read it without calling the function next to retrieve the headers. Next, let's consider a more complex example. Let's say we want to load the data into dictionaries where the keys have the attribute names as we see them in the headers of the file. By combining a dictionary comprehension, discussed in a previous video, with the enumerate function, this exercise is quite straightforward. Next, let's consider the JSON file format. JSON stands for JavaScript Object Notation, and it's a lightweight data interchange format. It's often used to exchange data between web services that could be written in different programming languages. And this is an example of a JSON file. This looks like a Python dictionary, but effectively it's JavaScript notation. Please notice the lowercase through. The JSON module in Python has two options to load JSON data into a Python object. First, we could read the file content in memory and then load the string into Python using the function loads. The final S stands for string. The movie object is now a Python dictionary. Please notice the true value, which is capitalized. Alternatively, we can pass the file object to the load method and the result is equivalent. If we want to output the Python object to a JSON object, we can use the dumps function, which also lets us define the indentation for pretty printing, like so. JSON data are often exchanged in JSON lines format, where each line of the file is an individual JSON object. This is the case of many web APIs and tools for database dumps. So this is a JSON lines format. Let's say we have this dataset of movies from the 90s, and for each movie we want to print out the title. Combining what we have learned so far, the exercise should be easy. Finally, let's consider the case for data serialization of Python objects. The pickle package allows to dump any Python object to a file in binary format. This file can be loaded into a Python object by another script. This is quite useful to share complex Python objects that cannot be easily serialized into JSON. So starting from a Python object, a dictionary in this case, the interface for serialization is the same as the one for JSON. Using the dump function, we can serialize the dictionary to a binary file. Please notice that the file has been opened in write binary mode. Being a binary format, the pickle file is unlikely to be readable by a human, so this is what a pickle file looks like. At this point, we could share the pickle data with other Python programs. In order to read the pickle back into memory, we need to open the file again in binary mode and simply use the load function. The data is now back into the original format as a dictionary. In this video, we have discussed how to access raw data from local files. We have seen some of the common data types used to represent data, like CSV and JSON. And we have seen how to use JSON and pickles to serialize data to be shared between services and programs. This is the last video for this section. The next section is about NumPy for array computation. In particular, the next video will discuss how to create NumPy arrays.